In this video, we want to talk about evaluating limits numerically, that is using table of values on the graphing calculator. Alright, so I have three particular examples here, and the reason is one has limit as a limit as x approaches 2, which is a positive number. One has a limit as x approaches 0, which is neither positive nor negative, and one has a limit as x approaches -3, a negative number. So hopefully from these three different examples you can get some idea of the types of values we're going to use to evaluate a limit. So let's bring up the graphing calculator and work with the first expression here. Alright, so we're going to go in and we type it in. You just have to be careful with a rational expression to make sure you have the numerator and denominator adequately enclosed in parentheses. So we have quantity x minus 2 divided by quantity x squared minus 4. Now if we were to take a look at this, let's zoom standard and see what the graph looks like. Obviously it's some kind of reciprocal function. We have a vertical asymptote at -2, but at +2 we're going to have a hole. So if we did second calc and a value at x equals 2, we'll see that the function is undefined at that point. Alright, so let's go in and see how we can use the calculator's table set and table functions to generate a list of values that will enable us to evaluate the limit. So we go second table set, and normally you have table start is 1, delta table is 1. So if I left those where they were and set independent to auto, then what will happen when I go into second and table is that you'll see I'll get a list of values starting from 1 and increasing by 1. So table start is 1, delta table is 1, which means it starts at 1 and it goes up by 1 each time. But this list of numbers is really not helpful to us in finding our limit. What we want to do instead is go into table set and set independent to ask. When we do this and we go to table, it no longer generates a list of numbers for us there, a list of x values. We have to type them in ourselves. So with approaching x equals 2 from the left, we're going to start with 1.9, then 1.99, and 1.999, and we could keep going if we wanted, 1.9999, etc. We could keep adding an extra 9 on that. But you should see that the values for y went from 0.2564, 0.250, 0.250, 0.250. The values are getting closer and closer to 1/4 without actually ever reaching there. And so that's what we're going to use here. And we'll fill in those values on in the table there. And now we'll approach 2 from the right side. So normally we'll start at 2.1. So we'll kind of start from the outside, then 2.01 and 2.001. And you can see that as we do that, we're getting to 0.2499999, which for all intents and purposes is going to be 0.25. So from this we can see that as we get between 1.999 and 2.001, right there between the values approaching from the left and the values approaching from the right, we're basically at 0.25, which is 1/4. And so the calculator allows us to find that. We could go some more values, as I said, 1.999999999 and 2.00001, and you'd see that you really are at 0.25 with a very, very, very small difference away from that. Alright, so that's approaching a number from approaching a positive number from the left and right. Let's go on to the next example, which is approaching 0 from the left and the right. So we type in the function, again making sure that we have the entire numerator enclosed in parentheses, and the denominator, since it's just an x, that doesn't need to be enclosed. But we have our function there. I'm going to do zoom standard again, and it appears that it's just a straight line, so we really can't see too much there. I'm going to take and change my y values to go from -2 to +2, and then regraph that, and there we can see that we have this little hook shape there. But in question is at x equals 0. So second calc value at x equals 0, it's undefined. Well, we're going to go back into our table set, make sure that that is set to ask, which it is. Go back to table. Now it doesn't erase the values that we had in before. But as we're approaching 0 from the left, we're going to use -0.1, -0.01, -0.001. And how many of these you should do? It's in this case there's only room for 3 of them approaching from the left and 3 approaching from the right. But I would like to see a little bit more here. 0.0001, and let's see if we're kind of at 0.28868. I would even see more. 1, 2, 3, 4, and 1. And I think we're kind of getting stuck at 0.28868. If I did one more, -0.1, 2, 3, 4, 5, and 1, we would have -0.28868. So that's approaching from the left, and I'll fill those values into my table. Okay, so we fill those values in, and then we can go up and approach from the right. The point is, when we're approaching 0, we're going to use -0.1, -0.01, etc. approaching from the right. And similar values, only positive, approaching from the right, 0.1, 0.01, 0.001, etc. And we're still coming into 0.28868, or 0.2887, rounded to 4 decimal places. And so in just the 3 steps that they give you in this particular table, the two sides have not come to an exact match, but rounding to 4 decimal places, we would definitely get 0.2887 in this case. And so this is an example of approaching 0 from the left and right, the types of x values we would use to approach 0 from the left and right. And we'll do the final example. And so again, just being careful to wrap the whole numerator in parentheses and the whole denominator in parentheses. We can zoom standard. And once again, we don't see a whole lot, so we'll go into window and we'll change the y min to -2 to +2, go back and graph, and we get something similar to what we had above, but kind of a downward shaping hook there. Alright, so we'll go in, make sure our table set is still set to ask, go into table, and this time we're approaching -3 from the left, so we actually want -3.1, then -3.01, -3.001, and here we see that we're definitely moving in to 0.25, although it's not exactly 0.25 by putting the cursor on top of that 0.25. it is very close to that. All right, we'll approach it from the right. Approaching negative 3 from the right, we're going to have negative 2.9, negative 2.99, negative 2.999. And so we're approaching the value of 0.25. And so we end up with a limit there of negative 0.25. All right, so once again, as we approach a positive number, such as 2, we're going to do 1.9, 1.99, 1.999. From the right would be 2.1, 2.01, 2.001. As we're approaching 0, it would be negative 0.1, negative 0.01, negative 0.001, etc. From the right, 0.1, 0.01, 0.001. So we're approaching a negative number, such as negative 3. We're going to have negative 3.1, negative 3.01, negative 3.001, etc. From the right, negative 2.9, negative 2.99, negative 2.999. All right, so these are examples of approaching a positive number, 0, and a negative number using the graphing calculator numerically. So hopefully that is clear, and we'll go on to another video.